Alright, good afternoon. I think this is where we left, right? We finished number 4, and I was attempting to enter the answer and it didn't work. I believe the question is correct, right? Okay. Now we learned all about line equations: slope, intercept form, point slope form, and standard form. Is it right? Okay. Just keep it a little bit gap. Yeah. Don't close it. Yeah, just don't close it. No. Just leave it a little bit open. Yep, there you go. Alright. Today we're going to apply and see where those line equations show up. And it can be, this subject can be now directly related to your fields. Okay? Nowadays, every business deals with cost, revenue, and profit. Right? So you want to know, you're selling some stuff, are we profiting from it? Or are your costs too much? And how much you're profiting? Okay? So mostly, basic model to see you're profiting or not is through linear equations. Alright, this C of X function is your linear cost function. What does that mean? Before even you produce anything, you need to go buy some tools, right? Rent a place, right? You need to get some permits. Before you manufacture, let's say you're a chair builder, before you're building your first chair, you need to get wood, you need to get permits, you need to run your electricity, redesign your place. So there is some fixed cost you need to come up with, like $100,000. That B stands for your initial out-of-pocket expenses before even building one single piece. Then every time you build a chair, there is some cost because you need maybe a ton of wood to create 100 chairs, but you need 2 tons of food to create 200 chairs, right? The more you produce, the more raw material you need, okay, whatever materials you need. So it's related directly to how many pieces you're building. So they won't come out of thin air, that you need to buy some materials to build them. So the most basic model for cost function is your initial startup money plus how many you build. X is the material, the cost of each unit you build. Okay. Now revenue is simple. You sell for a fixed cost, like each chair is $100, and how many chairs you sold? Like 100 chairs, $100 per each is $10,000. That's your revenue. At the end of the day, if you sell 100 chairs, that's the money in your case, all right? In your cashier box, okay? How about the profit though? And at the end of the day, you count your revenue and you pay off your employees and you pay off your bill providers, you pay your rent. When you subtract that cost and revenue, that's your profit. Okay? It all depends on X. X is, I said P is how many you build. No, P is the fixed price, P as in price. X is how many you build, okay? It all depends on how many chairs you build and how many chairs you sell. Okay, so our X is showing up everywhere. Alright, now these are just the definitions of a very basic business model using linear equations. Okay, very basic though, because there are some businesses, if you sell more, you give a discount. This doesn't include any discount. If you buy 100 chairs or 1 chair, it's the same price. So it's very simple, basic pattern. Here is one real application of this model. You are a loan service provider. Okay. Anybody here in third class? There is a major. What is it? Third management major? Nobody? I don't think they are required to take this class, but they should. I mean, it's good. So if you're a loan service company, you charge $66 for each loan maintenance call. $66 for each. Okay. The fixed monthly cost of 667 includes phone service and depreciation of equipment. I don't know. You have mowers you purchased, but each mower lasts like 10 years. You pay $60,000. Okay, I don't know. And each month, your mower is mower worth less and less. If you sell it right now, it's $667 less than what you bought last month. Okay, so each month you're losing money just because your equipment is getting older. Okay, all right. The other costs include labor, gasoline tax, amount of $34 per lawn. Okay, because you pay taxes to federal and local. To run mowers, you need gasoline, and you hire people, and you computed that for each service call, $34 is your cost, and you have also fixed cost every month. We are going to first build our cost function. And what is the initial setup for cost function? Let's see. You need to know three things. You need to start with three things, but you need to know only two items. Mx plus b is what you put down first. Let's do that. So I have mx plus b. When I explain what each one stands for, right? This is how many service calls or how many maintenance calls you answer. So this is calls, maintenance calls you answered that month. But before taking your first call, there was a fixed cost. Now what is M? M is, what is that? It's how much servicing each loan cost you, hiring people, gasoline, and taxes. So this is your per loan cost. And if you service 10 loans, it's 34 times 10. So this is 34, we already know. And this is unknown, we don't know how many, because it depends on how many calls you get. It should stay variable. But B, do we know B? To open this business, how much each month to keep it alive, actually? How much do you need each month? Because it says monthly cost. Every beginning of the month, you pay this price. What is that? Yes, $667. Again, this is monthly cost. It could have been daily, it could have been yearly. Some people do it yearly. They want monthly, and everything given here is monthly. Yeah, for cost, initial cost is monthly and per each loan. Okay. So this is it then. The answer is C of X is 34 30 times I don't know how many loans you service, time plus 667. That's your cost. Any questions on this? Okay? Oh. Our homework. Every time I click on the new homework, the numbers change. So I'm going to adapt the numbers according to my scenario. So it's 58, 657, and 38. Okay? This was 58, 657, and this was 38. Good. So how does this change? 38, 6, 57. Alright, let's give this a shot. Alright, this is done. There are 4 more parts. Next, we are going to compute revenue. If you answer X calls, service X many loans, how much money you make each month. Alright? So, can we just do it right on here? You have answered X many, you service X many loans, and you charge $58 per each. What's the total money you made after the first month? Anyone?
Wouldn't it just be 58 times X?
Yeah. Because we don't know exactly how many we answered, how many loans we answered, so it's X many. But you charge 58 per each, so it's 58X. Okay? Again, remember the revenue formula? It's price you charge times how many calls you made, or in other words here in chair example, how many units you sell, right? Whatever service you're providing. Okay, let's check out the next one. Write a linear profit function representing the monthly profit. Now you're going to write up your profit. Here is my cost, C of X, and I already know my revenue. Revenue is 58X. This is my cost, right? Cost. How do I get the profit? This is how much to run this business cost me, and this is how much I made after the first month. Profit will be their difference, right? P of X is C of X minus Rx, right? What is C of X? Is that right? Should be the other way, right? You subtract cost from the total money you made. So I need to flip this. So this is revenue first, and then cost next. Now what is our revenue number? 58X. What is our cost number? Yes, right? Is that right? I just put Rx first. This is Rx. And then cost next, right? If you put this answer, yes, you will have a mistake. Because it looks like you're subtracting only 38X from your money. This is total money you have in your pocket after each month. And you're only subtracting this, and it looks like you have 600, somebody gave you, donated $657. This is look like plus, you see? Looks like in my pocket. No, you already spent this. So where is the mistake here? When you're subtracting C of X, it's 2 items, you need to keep it in parentheses, and this past this minus in. Now you're going to have 58X minus 38X, which is, what is 58 minus 38? 20X, but no longer plus 67, it is minus 657. Okay? It is minus. This should switch to minus, and this should switch to minus. Now when I combine these, I got 20X minus 657. Any questions? does it make sense if you don't answer any calls in a month, meaning zero service? What is the total? Negative 657. You are losing money because you need to keep your business open, you need to pay taxes and phone service and other stuff. So if you don't make any calls, you are losing money, $657. All right, part 4. How many maintenance calls you need to make each month to make money? Okay? You need to be positive. If you don't make any calls, you're at negative 657. You need to break even and get a few dollars in your pocket. How many, what calls do you think you're gonna make or more so that you can make a little bit of profit? You need to stay more than zero. What do you think? Right now, if it is zero, it's negative. You can try this, 1, 2, 3, 4, 5. But trial and error may take a while. Is it 10? 20 times 10 is $200. 20? 30? I don't want to do trial and error. You're getting close though. 30 is close. How can I get that exact amount? Solve for x? But I need an equation first, so you need to set this into something. What do you need to set it into? So this is your formula, profit. So part 4. You take this profit function. Do you want to set it into 0? Right? This is the recipe. If you want to break even, you don't want any profit, you don't want any loss. This is the recipe. But the question says, I don't want to lose money. I want to break even or more. So this doesn't cover the more part. So how do you revise this so you can make more? Perfect. We need to change this into profit should be 0 or more so you can make money or break even. Right? So I will solve for this. Let's solve. Add 657 to both sides and divide. And 20 divides both sides. Alright, I need a calculator. What is that roughly in decimals? What is it? 657 over 20? 20, no, 30. 32.85. Well, this means you need to make 32 whole calls. You need to service 32 loans, and you need to live in the middle of the next job or a little bit past. Call the homeowner. I won't be able to trim the loan because I need to stop at 85%. Can you do that? No, you need to complete that job, right? So that means we need to round off to the next number, which is 33. If you cut 33 loans, then you're gonna start making some profit. Good. Next, you did better than 33. You took maintenance calls of 32. How much money are you going to make or lose? First of all, are you going to make a money or lose? You can determine this in 2 seconds. If you answer 42 calls and service 42 loans, are you going to make or lose money? Because 33 is almost your break even or more. You're making a few cents, right? $dollars. So 42 definitely will make you some money. Let's see how much. Will make us how much? You just need to plug in 42 here. This is your profit. This is how much money left out after the cost. Just plug in here 42 and subtract from 657. This is what we are using. Okay. Anyone? 183. That's rounded off for a whole number. Okay. Good. You're right. Any questions? Does it make sense? You were asking me where do we use those inequalities, linear equations. Look, an inequality, a linear equation, all from part of real life. Here's another example. You're a pet owner. You have a puppy named Dodger, and you measure Dodger's weight for the first 2 months. You take measurements. You can't measure every day, but you took some measurements. Like when you first got the Dodger, this is the Dodger. Okay, puppy. I think it's a male name, right? Okay. So his weight was a little bit past 10. After this is about 5 days. Yeah, it says 5 here. 5 days later, 12.8. 10, maybe this is 12, 13. 13 days later, you have about 13, and this is 18, it's about 17. So you have some measurements. It looks like you measured every 5 days or 10 days sometimes. You took some time sometimes, 8 days. And this is your dots. Now what does it look like? When you connect those dots with the best fit line, it's a straight line pattern with a slope, right? So usually weight increases in a straight line pattern. Okay, what is the question here? Is this clear? Do you know how to read this? Right? Up 60 days, 2 months, your puppy is about 27-ish pounds. Good. Alright, let's read the question. But first, let's see, compare this to mine. We copy this one. There you go. Revised picture. Alright, here is our question. Use 2 points on this curve given to find out linear equation for this data. There is a line here. You're going to use these 2 points given, to find out its equation. What is this line equation? Alright. They want the answer as, it's clear what format they want. What kind of line equation do we call it if y is all alone? It's called slope intercept, mx plus b. Because if x and y together we call it standard, and there is also a point intercept form, point slope form, that also has y with some other number. This is point intercept, slope intercept form. So they want our answer in slope intercept form, so you need to start with that. Y equals mx plus b. They want the equation of this line, that's it. Well, I need to know M and B. First off, let's start with the easy one. Do you know what B is? Do you know it? Alright. Say it again.
13.2, 48.
Where is 13.2? Oh, you computed it? Okay. But directly we don't know it, right? We don't have a direct answer. It's this one, this is y-intercept. It's more than 10. Are you sure it's 13 though? Because if it's 13, it needs to be higher up here. It should be less than 12 because I know at least this point is 12. This point is 12. I know it's something between 10 and 12. That B. But we need to compute it.
That's
Oh.
14.
What's that?
That's 14.
Oh, sorry. You're right. Now you're good. You may be right now. Okay. That point is 10. 13 is between 10 and 14. So you may be right. Okay. But B is to be computed. Do we know M directly from the line? No. I'm going to start with M. Well, check what else, what's given. You are given 2 points on this graph and nothing else. There is a line given, but I don't know this number, I don't know that number. Only 2 dots given on it. Literally, there is nothing but just 2 dots here. One here, this end, one is there. You don't know any other dots. So you cannot compute this slope from the graph by going rise over run. It's not going to work. We need to use these 2 dots. And what is the formula? There you go. We're going to go with that formula. M equals y2 minus y1 over x2 minus x1. What is y2? The second point, y coordinate, 27.5, minus, what is y1? 14.3. And x2, 60, x1, 12. All right, somebody take the difference, divide, and tell me he's right. Are you right? 13 point. What is it?
13.2, 48.
2048. 48.
411 over 40.
Or I need the whole real numbers. Don't round off. 248.
What?
13.2.
2. Next digit. That's it? 2. It must be terminating. Is it terminating?
That's
I mean, are there more digits after 2? That's it. Okay, thank you. Yeah, because if you round off, if this is 19 and you round off, the system may say it's wrong. Don't round off anything. You should tell the whole digits. Okay, so we have M known now. 13.2 x plus b.
That's 13.2 over 48 at last and 48
Oh.
after reciprocal.
Okay. Okay, that's what you mean. Perfect. But when you divide these 2 numbers, do you have a decimal value?
Yeah.
Is that ending?
Yeah. 1,
If it's ending, you feel free to turn this into decimal. If it's not ending, like repeating 3333, don't change it, keep it this way. I like this way if it's not ending, but if it is ending, tell me that result.
2.
0.275. Perfect. Alright, how do we get B? I know it's something between 10 and 12. How do you get B?
So that's
Say it loud.
you put one of the parentheses in the problem. So like 12 and 14.3.
Use one of the coordinates in the parentheses. Perfect. So the first one is x, the second one stands for y. Just replace these in x and y in your formula and solve for b. So 14.3 is what I see here, right? It goes into y and 12 goes into x. Let's do it. 14.3 equals 0.275 times 12 plus b unknown. All right. Now multiply these two. .3 and subtract from 14.3 should be 11. Agreed? Am I right? I told you it's not 13. I'm just kidding. Okay. But we got B to be 11. And this was 0.275 x plus 11. I hope I'm right. Good. Let's understand how do we use this line equation now. What's the number in front of x in a slope-intercept form? This number? It's slope. And they mention it here. Interpret the meaning of the slope in the context. What does this slope tell you? Doesn't slope tell you how much your line goes up and goes down in every second or in every whatever the unit is on this picture? So what is every piece on this x line stand for? Is it 1 minute, 2 minutes, 3 minutes? It's years, days. So each day your line is going up at what rate? 0.275. That means each day I'm going to write, each day my puppy is gaining 0.275 pounds, right? That's what slope means. So weight increased by 0.275 pounds per day. Alright? It depends on the graph. If it's minutes, that's the scale you use. If it's years, that's the scale you use. Okay? Now, what's the meaning of y-intercept on this picture? Here's y-intercept. We found it 11. Remember? This number we found here is y-intercept. That's this location. What's the meaning of it? It's a weight, but when? At day 0, when you first acquire puppy. Maybe birth, is it? I don't know if it's birth or, but it's day 0. So the intercept 0, 11 indicates Dodger's weight the day he was adopted, right? And it was 11 pounds. Alright. When do you think Dodger is going to grow 90% of his expected weight? So statistically, these puppies are grown into 70 pounds eventually. But I want you to guess when this puppy is going to reach at 90% of this 70-pound range. First off, let's compute 90% of 70. What is 90% of 70? Alright, that's 9%. 90% means 90 over 100 of 70 pounds, right? Multiply these two, divide by 100, which is 63 pounds. So this puppy eventually will reach at this 63 pounds. But when? Can you read it from the graph? No, graph is only up to, what is this number? Is up to 27.5 pounds. I know in 2 months he's gonna be 27.5. But when is he gonna be 63? 4 months? 6 months? This graph doesn't tell you because you forgot to take measurements. That's the benefit of having an equation. Now you have the equation, you can even guess what's gonna happen 3 months later, approximately. 9 months later. All you need to do is here enter the day amount into X. Okay? But here we are looking the question from the opposite angle. We want when the puppy will be 63 if he grows 2.75 pounds each day starting 11 pounds. You have 11 pounds at 0 and you're growing 275 each day. How many days it takes me to get 63? That's the setup. Got it? So in other words, that's 63 substitutes y, and you are looking for a number of days. And somebody do the math. Take 11 off, which is 52, and divide by 0.275. How many days is it? What is 52 over this? 200, what? Almost 200. Right? 189. It's more than 6 months. Right? 6 months and 9 days later, your puppy is expected to be 63 pounds. Is it guaranteed? No, this is a model. It may be wrong. Some puppies never grow into more than 40 because you're a bad owner. You don't feed them. Right? Okay, but statistically, average, they reach up to this height in 6 months. Okay, the last one. I mean, math always doesn't make sense. I mean, if you just extend the limits of math, you make a huge mistake. Because some people think what happens in the 100 years later, what's going to happen to this puppy's weight 100 years later? It's going to keep going and going into moon, right? It's going to be an elephant, right? Is it going to really happen? No. This range is sustainable until maybe 1 year or a couple years, and then they stop gaining weight. So that's what it's asking. Always keep your logic on the side when you're doing any modeling. Is the model reasonable for the long term? No, because that line is going to infinity. No, it's not. Badger will eventually stop growing, right? Okay. Much better models, when we go to logarithms, you will see that weight is actually best described by this model. What is the difference? This doesn't go to infinity. This slows down and stays under some level. It's called logarithmic model. This is linear, straight. This is curvy. It slows down when you grow up, and you will never pass something more than 70 pounds. Okay, this is all. This is all about linear equations, lines, over. Any questions? Okay, we're going to go take a break from this chapter, chapter 2, but we will come back to it. We will first cover chapter 9, 2 sections from chapter 9, kind of break from functions. We are going to solve system of equations for a while, Then come back and finish chapter 2. Okay? So we are going to section 9.1 today. Any questions though? Alright. We have about 10 minutes, 15 minutes. Okay. We can do a little bit introduction today. Now where does this happen? I said system of linear equations. System means you will have more than one linear equation. Typically we will first see 2 equations. In this section we will see 2. And in the next section we will have 3 equations and 3 unknowns, 3 letters, variables. Okay, where do they happen? This is a good example. It happens when you're selling tickets to an event. Because you can pretty much produce unlimited amount of tickets, like 1 million tickets you can print out, right? Are you going to be able to sell it? No, there are 1 million people in town to sell, first of all. Secondly, it may be too pricey, too expensive. Even you have 1 million people in Ohio, since it's too expensive, not everybody can make it. So you need to find that sweet spot. You don't want to produce infinitely many tickets, some amount that people are willing to buy in a comfort zone, not too cheap. You don't want to sell too cheap. But you don't want to sell expensive because only 500 will sell. There is a sweet spot. You can maximize your profits. Everybody, you sell to most people for the best price. Not too expensive, not too cheap. Okay? And that can be solved, that sweet spot, by setting those 2 equations. These 2 coordinates, one for x, one for y, can be found by solving this linear system of equations. How many equations do you have? One for supply, 0.02x, one for demand, 0.03x plus 100. And when you solve x and y, I will show how, you will find the sweet spot, 2040. That means you need to price each ticket $40 and produce 2,000 tickets. Okay? Alright, that's a demonstration of how useful solving these things can be. Alright, again, that system is called system of linear equations. That sweet spot I call solution. Alright? That's what we are trying to go. And sometimes you may have more than one solutions, even infinitely many solutions. Those are some exceptional cases. But in real life situation, you will have only a unique solution. We call it one single solution, unique solution. And we put them in set parentheses like here, once you reach out. Here is your first question. Don't worry, you're not starting to solve them yet. First, I'm going to teach you, if somebody tells you 4, 2 is a solution to these equations, or 3, 1/5 is a solution to these equations, how can you test if this guy is telling the truth? If somebody says, let's sell 4 tickets, $2 each, okay, or 3 tickets at $1/5 each. Would you trust it? How do you know it solves your demand and supply equations? How can you test this out? What? Plug it in. Right. First number in the first component is for x. The second number in the second component is for y. You just plug them into not only the first equation though, but second one as well. You supply these into both equations. It must solve both of them at the same time. Just solving the first one, satisfying this first one, but not satisfying the second one is not enough. So there are 2 parts here. I'm going to do part A because it's easy. I don't like fractions. But if you like, you can turn 1/5 into 0.2 and plug it in. But 150 is not too bad as well. You're just gonna deal with fractions, set common denominators, etc. I will do 0.4 and 2. Basically, I put 4 every time I see x, and I put 2 every time I see y, and compute the equality. Now, technically, I need you to put a question mark here first. Because do you know these two are equal yet? I don't know it yet. I'm suspicious. So I'm putting a question mark. I will compute the left. Reduce the left side, right side, and if I see them matched, then I will put a check mark. Yeah, they're equal. Okay. So how do you do this? Okay, I see some bunch of operations. I see easy one first. 4 minus 3 is 1. This is easy, right? And 8 times 1 is 8. And then 2 times of it 16. Can I just do it like that? Can I just start in the middle because I see 4 minus 3 is easy? No. You need to follow the order of operations. You must do first products before subtraction. So I will do this and that first. That's minus 32. This is minus 6. Now you can combine this and make negative 38. Now how about the right side? Are there any operations required on the right side? No. You just keep repeating it until you see them matching. And now you can put a check mark. Those two numbers verify the first equation, so we can go say yes, this is a solution, right? Can we? No, not yet. We need to verify the second one as well. So far, this one checked out the first guy. How about the second? I will substitute 5 and 4 minus 4 and 2 and see if it's 12. Again, question mark. 20 minus 8. There you go. This is 12. And it checks out. This was still question mark. Now it's no longer a question mark. It's an identity. So we have our first one correct. We are doing 9.1. Homework 5. Okay, it looks like a short homework, but the remaining questions will take longer, trust me. Is a solution. What do you think this one is? I don't know it, but you can test that, okay? But again, you'll be dealing with fractions here. Do not use a calculator unless it's terminating. This is not terminating. So don't change this into decimal and plug it in. Then you won't have matching numbers. You need to work with fractions here, set common denominators and stuff. Okay? So I'm not gonna spend time on it. It's just basic algebra. Alright, let's see how much time we have. 5 more minutes. Okay. Now, there are 3 results you can get in a solution of a system of 2 equations. As we got in the first problem, you may have a one solution, unique solution. Those 2 lines are crossing each other. One location sweet spot happens. Or they never meet each other. Those 2 lines are parallel. You will have no solution. No pair of x and y makes those both equations correct. Nothing. We will have that case as well. And sometimes those 2 lines look different, but are these 2 equations are really different? Look at this, the second one. You may say they are different because this is 1x, 1y, and minus 1. This is 2x, 2y, and minus 2. But are they really different? This is just somebody multiply the first equation by 2. If you multiply this by 2 and this by 2, you get the second equation. So the looks are kind of deceiving. You may say those two equations are different. You may get a sweet spot single solution like this one. But no, if the second equation was just a multiple of the first one, you will have those two lines they will coincide. These two lines are coinciding on top of each other. Every point on this line satisfies both equations because they are the same equations. Whatever x and y you take here is also in the second equation. So we may have unlimitedly many, infinitely many solutions. But these are rarely happens. These are exceptional cases, but it may happen in our questions. Okay? Usually we get one unique x and y values. And that will be done in 2 coming up next. And we will follow these recommending steps. It takes a while, and if you rush, it's dangerous. You may have mistakes, okay? So we will start this tomorrow.